Relay setting in overcurrent room, part 1. As mentioned before, after configuring the relay, the first step is to enter the relay characteristic in the software. To do this, first how to enter the setting for a non-directional relay is going to be explained. Enter General Test Object window, and after changing the CT turns ratio to 500 to 1 in device block, by double-clicking on overcurrent block, overcurrent protection parameters page opens where you can enter the relay setting. In Relay Behavior section, the setting related to relay protection, placement of VTs as well as wiring of CTs are specified. Since here our relay is non-directional, non-directional should be selected in this window. Note that the setting related to VT connections and CT connections are only active in directional mode, and in non-directional relays these options are disabled. In directional relays, current, time, and angular tolerances are set in Tolerances section. To set current tolerances, you need to enter your intended tolerance as a percentage of the test current in relative field. You can see that this tolerance is set at 5% by default. Also in absolute section, it is possible to enter this tolerance as a coefficient of CT nominal current in this field and view its actual value in the front field. Moreover, it is possible to enter the numerical value of tolerance and view its related coefficient in the previous field. For example, in this field 40 mA is entered as the tolerance. You can see that the coefficient related to this current changes in the corresponding field. Note that the software picks the maximum tolerance between the two tolerances specified for the characteristic curve. For example, if the test current is set at 1 ampere with a 5% tolerance, the current is calculated between 1.05 and 0.95 ampere, but if a 40 mA tolerance is used, the pickup current is calculated between 1.04 and 0.96 ampere. The software picks the highest values, which is between 1.05 and 0.95 ampere. In time section, the time tolerances are specified in percentage and actual forms, and the angular tolerance is specified in angle section. To specify the characteristic curve, you need to enter Elements tab. In Elements name column, a title for the specified stage is entered. For example, here stage 1 is selected. In Tripping Characteristic column, it is possible to specify the type of characteristic curve, which is set at IEC definite time by default. To change the intended characteristic curve, double-click on IEC definite time or click on 3 dots sign from Characteristics section to open Manage Select Characteristic window. In a Standard section, you can view the available characteristic curve in IEC Standard, and by selecting any of these, you can view its formula and coefficients in Characteristics section. Note that it is necessary to select the same characteristic curve as the one specified for the relay. If you cannot find the characteristic curve specified for the relay here, or the coefficients of the formula are different, by entering Predefined folder, you can find the relay characteristic curve from Inverse, I2T, IAC, and Reclosers folders. Also, if you cannot find a relay formula in any of the folders, in Custom folder, by selecting Custom Formula, it is possible to specify your intended formula according to the coefficients specified in this section, as well as the value of the iTest pickup and time dial, which are indicated by M and TD respectively. After doing so, you can save and use the formula. Moreover, if the relay characteristic curve is based on the points table, you can add the characteristic curve point by point and view its curve by selecting Table Example 2 and using the grabber tool available in the software. This window will be fully explained in the future videos. If the characteristic curve formula is available in the software but the used coefficients are not the same as the ones in the relay manual, you need to select the intended formula, and by copying and pasting it in User Defined section, change its coefficients and use the formula according to the coefficients specified in the relay's manual. For example, here the formula related to Basler I2T 46N curve is copied and pasted in the User Defined section. Now by selecting it, you should enter your intended coefficients, and by saving the new curve with the selected coefficients, it is saved in the software and can be used. To continue the process, the IEC normal inverse curve is selected here. You can see that in Elements tab, an inverse normal stage is entered. Now, in iPickup column, you should set the pickup current of the relay according to a coefficient of CT secondary nominal current, which here is set at 1.1. Also, it is possible to set the pickup current from iPickup field at the bottom of this tab. After setting the pickup current, its value is displayed in absolute column. In time column, TMS or time dial of the relay is entered. This value can also be entered in time index field at the bottom of this tab, and 0.5 is entered here. In reset ratio column, dropout coefficient of the relay is entered, which is set at 0.95 by default. Also, you can see that in direction column, the type of this curve is set at non-directional.